So this video is on assembly drawing of Plummer Block. So Plummer Block is used to support bearings, and here this demo is on drawing of Plummer Block parts and assembly drawing of Plummer Block. So here I'm showing this picture of a main part of the Plummer Block, that is body. So front view and top view of the body is shown here. So front view with right half inch section, and the top view is shown in this figure. Okay, how to do sketching of um, this assembly drawing? First we'll start with before that. So what is the question is like this. So question is front view with right half inch section. Front view, it is not complete section, it is front view with the right half inch section, and then top view. So two views or so a drawing of two views. So before you start drawing, you plan how to uh, proceed, because here you will be using A4 sheet. So this drawing should fit in A4 sheet. Here side view is not asked, so I'm not drawing the side view. So side view, if left view is asked, then you need to draw left view here. If right view is asked, then right view should come here. Okay, so this is the format. So the drawing should fit in the A4 sheet. So basically there are minimum three views. Three views will be asked. So but here for space constraint, I'm doing only these two. Okay, so front view and top view. See that these two views will fit into the drawing sheet. So this is the sheet that you will be using. So here front view and top view should come here, front view above and top view below the front view. So don't draw top view in next page or like that. Okay, so please don't do that, because you need to follow the standard. Okay, so this is orthographic projection. So front view, below front view is top view, and next to the front view should be the side view. It is like this. Okay, so front view here, so top view should come exactly below this, and side view on any of the sides. Okay, so if it comes here, then it will be left view. So right view should come here. So this is the template, and you should follow this, right? The method of orthographic projection. So and here it is first angle projection. It is the first angle projection, that's why top view comes here and the front view comes here. If it is third angle projection, then top third angle projection, it will be like this: top view here, and below top view the front view. Okay, so here we are following first angle projection, so front view and the top view. So I need this much space, so please plan for the space so that it can be accommodated in the drawing sheet, and then proceed. So here so I will leave some space, this much space for front view, and below bottom portion of the sheet is for top view. Okay, so what is the size of the complete assembly? Complete assembly will be around some around 80 to 90 mm. So I can leave this much space, and width is around, it is 170 mm. So 170 I can accommodate here. So this drawing sheet, the width is 180, so I can accommodate. So top view here, so top view and top view will come here, and front view will come here. So I will start with front view. So front view with right half inch section. So this is the XY line. Or we can do like this also, that's also possible if the space is sufficient. The width is 40 mm, and this is okay. So let's do like this. Okay, so landscape. So that is also possible, because if side view is asked, then you should know how to draw the side view also. Okay, so front view, top view, and side view. So I need this width is of 170 mm, so I will take up to here. So this is the XY line and baseline for um, baseline for the front view. Okay, so XY line. So the thickness here is 14 mm. So I'm drawing to 1:1 scale. Okay, scale is 1:1. So whatever the dimension, so same dimension I will take. I will not reduce the dimension. It is 1:1 scale. So here it is 14 mm. Thickness is 14 mm. I take 14 mm. To 14 mm. So exactly at the center, that is at 70 mm. So this will be the center, that is axis line. So here we'll take this as the center line. So then I will start with the height. Height is 55 mm. So measuring 55 mm from the uh, bottom line. So from here it is 55. So it comes here. So 55. So I will draw the arc. Arc is of so instead of the radius, the diameter is given. Diameter is 38. That means 19 mm. So radius is 19 mm. So this is the center. Okay, sorry. It is the height is 55. Okay, so this height is 55. From there, it is I need to, yeah. Uh, I will draw. I will take this reference. It is 22 on either side. And vertical height is height is 12 mm. And then this is 38. 44 minus 38 is 6 mm. So this distance will be 3 mm. So total difference is 6. So on either side, if I take, then it will be 3 mm. So it is 3 mm, 1, 2, 3. So on this side also is 3. So radius is 38. Again I need to take 3 mm down. The distance of 3 mm from here. From here it is 19 mm. Then a straight line connecting these points. So it is like this. I will make this arc darker. So now from at the end it is 4 mm from the top on either side. So taking 4 mm length on this side and also on this side, 4 mm, and join these two points. It is 170 and 80 is 160, 84, 84, 84 mm on either side. So it's 84 mm either side. It is not 170, it is 168. 168 here, so 84 on this side and 84 on this side. So here it is going little outside, so take care that it's okay. It's because it's difficult to complete in A4 sheet. So it is total length is 168. So it is 84 from here, 84 mm here. So I will draw a vertical line, and from there it is 4 mm. So it is this line, and then from center it is 84 mm. So from top I will extend up to this, and from here I will take 4 mm. ಒಂದು ನಿಮಿಷ ಇರಿ, ಒಂದು ನಿಮಿಷ ಇರಿ, ಒಂದು ನಿಮಿಷ ಇರಿ, ಇರಿ ಇರಿ ಇರಿ. So actually, in the beginning, I considered this distance as 170. So that's not correct. Actually, it is 168. And also, while taking dimension, I made a mistake here. Okay, so please correct, because this is a center line. From here, I need to take half, exactly half of 168 is 84 and 84 from this reference line. On this side, it is 84. On this side, it is 84. Okay, so. So height is 14 mm. So height is 14. That is correct. Okay. Right. So now I will take this dimensions from the top as a reference, because this is the reference line. I will take reference from here. So it is, what is the distance from here to this last line? It is not given in the front view. It is given in the top view. Okay. So top you see, you can see that radius is 43. So it a arc of radius 43 in the top view. So therefore this distance from here is 43, 10, 20, 30, 40, 43 is to here. From the center, it is to a length of 43. Okay, so 10, 20, 30, 40, 43 up to here. And then from here I will draw a vertical line. Then I will make this dark, and then from here it is dark like this. Next, taking reference for the holes here. So that it is of width 10 mm and semicircular on either side. So it is at a distance of 128. That is, from the center it is 64. So I will measure the distance from here. It is 64, and again on this side it is 64, like this. So this is the axis for the hole, and here also axis for the hole is, the total width of the hole is total width is 8 plus 10 mm, that is 5 on either side because of the arc, and 8 mm. So it is 10 plus 8, 18 mm. So I need to mark 9 mm on either side. So 9 mm here and 9 mm here. So here I will show with the dotted line, because it is not visible. So but here it is visible, because I'm showing from this side it is with section. So it is visible on this side. So 4 mm, oh sorry, 9 mm on either side. So 9 mm and 9 mm here. But it is not complete. The vertical line below that is a slot. Okay. So uh, slot of um, 7 mm. Sorry, not 7 mm. It is 2 mm. It's a 2 mm slot in the bottom face. So on this side it is not visible because here I'm not showing section, so I have to show with the dotted line. So on this side I can show like this because it is visible section view. Okay, so again here it is not complete throughout the section, and it is a distance of 8 mm. Okay, so there is 8 mm from here. So 8 mm from bottom, 8 mm measuring from the bottom. Okay, so 8 mm, here it is up to, okay, from the center also 8 mm. So the view is like this. So since we are showing the front view with right half in section, this portion should come in section. So this is without section. Okay. So right half in section, the right side of the observer. This is the right side. So right half in section. So this portion I have to show in section. So I need to show the inner details of the part on this side. So there is space for a bolt here, which is at a distance of 62 mm. Sorry, 31 mm from the center. So measuring 31 mm. So the 31 mm here, I will draw the axis. This is the axis for the bolt hole, and then there is it is a rectangular headed it is square head bolt hole. So there is a square hole here, which is height is 7 mm. So height of the square hole is 7 mm, and its width is 20. That means from here it is 10 mm like this. So I no need to draw the dotted hole because this is visible. So it is like this. The diameter of the bolt is 10.5 mm. So from here it is 5 mm on either side. I can't measure 0.5 mm, so I'm taking 10 mm. But in software, you can draw actually to the 10.4 diameter of the hole. 10.5 you can make it, but here it is the least count is 1 mm, so it is not possible. I will make it approximate to 10 mm. So this is the space for the bolt. The bolt will come here. So it is like this. So try to draw exactly as it is, um, as per the dimension. And so it is mentioned that wherever the radius is not mentioned, unless otherwise specified, the radius is 1 mm, that is mentioned in the drawing. Also, this minute details, you can just make it like this. Right. So so this is not actually completed, but major part of the body is completed here. Now I need to assemble. Before that, let me draw this hole also. Diameter is 6 mm, so it is 3 mm and 3 mm. A depth of 6 mm. So here I will draw two dotted line. So here I will show the continuous line for 6 mm, and then select this. The same there is symmetry about this axis, so I will take this dimension on this side and this dimension on this side. So this is for the axis, and this is for the bolt. This is square head of the bolt. I'll take measurement from here. This like this we can save time. Okay, so since it is symmetry about this axis, I can just measure, copy this dimension on this side, so we can save time. So now part number 2, I will add that image. So now cap. So center is actually, it is the center is the same center of the cap and the center of the body should coincide. Here from the center of the uh, cap. So from here, so the radius is so radius is 19. So I will draw a arc of radius 19. Okay, so this is just for a reference, but actually the bearing bottom half and bearing top half will cover this portion. Okay. So now from the center, I have to take a distance, height of 6 mm. So from here, it is 6 mm height is up to here. Forty-four is the width, so I'll take 22. 22 is, it will touch this much portion. And then so this vertical distance is 12 mm. From here, it is 12 mm distance. So like this. And then from there, it is to a distance of 43. So 43 means it is up to this line. And then 10 mm from here. Then drawing a horizontal line. Okay, similarly, I will take a projection on this side. So like this. So one more arc of radius 36. So remember this, the constraint here is this is the body and this is the cap. So after body, bearing bottom half will be inserted, then the shaft will come, then bearing top half, and then the cap actually. Okay, so here since I am getting the reference as the center of the body and center of the cap, I'm getting a reference, so I'm just taking that reference and inserting the cap. Okay, in actual procedure, what they will do is they will insert the bearing bottom half on the body here, so which aligns with this this axis, and then the shaft will come, then bearing top half, and then the cap will be inserted. So now take the project. I will complete this part. Just a minute. And then so the axis, so here, and then um, this hole is also visible. That bolt will come here. Okay, so I will just extend this because it is the bolt. This is the bolt. So I will show the bolt head. This will become continuous line. This also becomes continuous line, and then I can erase this. No, this is not required because the uh, bolt view comes here. Okay, so it is like this. So length of the bolt is uh, so length of the bolt. I will add that image. So So length of the bolt is 75 mm. Shank length is 75 mm. It's measured from here. It should be 75. Okay. I think it is 75. It seems to be 75. Okay. 75 mm comes up to here. So two nuts will come here to clamp this assembly. The two bolts and four nuts. Okay. Yeah. Okay, similarly here I will show the bolt. So bolt is visible in this gap. This gap the bolt is visible, and it is up to this length. So now I will take this bearing bottom half. And here, okay, so before that let me um, draw this oil holes. It is at the center, and diameter is 6 mm. So from here 3 mm on either side. So 3 mm, and to a depth of 10 mm. And then the diameter is reduced to 3 mm. So So 1.5 on either side. So it is right side it is visible, on left side it is dotted line. So I will make that as dotted line. So like this. So now I will include bearing bottom half and top half. So here it will be seen as this circles. So the diameter of the circle is 50 mm, which coincides the axis of this bearing bottom half and top half. It coincides with this center. So it is 25 mm is the radius. So taking the radius here. I will draw a horizontal line reference, and then comes 38 mm, so which is already 38, that is there. Okay, and then one more arc of 35, that is 70.5. So now the next part is the shaft. So I need to know the diameter of the shaft. shaft and nut. So it is 25 mm, diameter of the shaft is 25 mm. Just take 12.5. So now the lock nut and lock nut. So small one is thickness is 5 mm. Is 5 mm is the thickness. We'll take thickness is then the bigger one is of thickness 8 mm. So it is show the chamfers. Actually, you should follow the procedure given in nut and bolt chapter to draw this. But here, because of time constraint, you can show like this. So like, and show threadings because this portion is threaded. So show threadings here with the chamfer. And here also with the threading and chamfer. I will draw this first. 5 mm and then for 8 mm. So for details about the nut, please refer nut and bolt chapter. There you will get the actual procedure to uh, draw the views of the nut and bolt. So since the right side is the sectional view, you should show the section. So section view, you should draw the lines showing section. It should be a 45 degree. So like this, you need to fill this area which represents the section. Don't hatch the nut and bolt. This I should not hatch that. Hatching style should not be same for these two are different parts. So hatching style here I'm showing like this, but for this it should differ because these two are different parts. Okay, so this is actually major part of the front view is completed here, and I will not go further because you can complete that remaining part. Ballooning, showing major dimensions, other things, you please do it. Now the top view of this assembly, so top view of the assembly is like this here. So the total distance This 36 is the width of the 36 mm. So I will take 36 mm this. This is the reference line. This is the reference line. So top view. We'll take projection. We'll take projection from here, from these two ends, like this. So width is 36, 18 mm on either side. And 18 mm on this side. So center is this portion here. From there, I will need to take the arc of radius 43. We'll draw this arc on this side. Similarly, arc on this side. Okay, so now I'll take the projection of this to the front view. And here I need to show the dotted line. And then a arc will come here of radius 6. For that you use pro circle and use pro circle and draw the arcs. This arc. So here also get an arc. Please use pro circle for this. In the top view of this, this you will you need to show this slot here, and it is at a distance of 8 mm from here. From here it is 8 mm, and from here it is 8 mm. So I'm not showing the section view here. It's a top view of the body, and from this end it is 8 mm, so it is up to here. So then the bolt and nut. So please use Pro Circle for this small curves and circles, because it takes too much time if you want to do by using compass. Okay? And also you will not get a good curve because it's a small curve, so you can use Pro Circles. So this is the top view of the bolt, and for nut, top view of the nut, and then on this side. So show the top view of the nuts like this. Okay. So here comes after this, the top view of the cap. So top view of the cap is like this. So it coincides with this line. So it will overlap on this edge. So it's okay. But oil hole will come here. We need to show the oil holes here. Please use pro circle. Okay. And then so bearing top half and bearing bottom half, this will fit here, 36 mm will fit here. The remaining will project out, and its distance is 50 minus 36 is 14 and 7 mm outside. Okay, so we will take this projection outside. Projects out by 7 mm on this side, on either side it is 7 mm. So here it is measure 7 mm, outside is this 7 mm here and 7 mm. So like this, then the shaft will project out. I mean, it is the support for the shaft. So this is a bearing and it supports shaft. Bearing bottom half and bearing top half will hold the shaft in position, and with the cap the entire assembly is held by the bolts, by clamping the bolts. And this way, and this is for oil holes, so with this oil will flow and provide lubrication for the smooth rotation of the uh, shaft. So this is what complete this. Okay, so shaft bearing bottom half on top half, and the cap, and the entire assembly like this. I have not drawn this view. You please draw. It is just like this. Okay, so like this it comes here. And if side view is to be drawn, then need to take the projection here. So I will take the I will draw the reference lines for side view. So this is the intersection point of XY line. From here I will draw 45-degree line. 45-degree line. So now you need to take the projection of this. Side view should come here. So this is the left view, because I'm the observer. I'm looking at this drawing from this end. Okay, so this is the left side of the observer. This will be the left side of the observer. So if you viewing in this direction, the view will come here. So the view is left view. So take projection of this and projection of this, taking projection here. We can take the projection of front view and projection from top view and complete the side view here. Okay, so left view. So this is the procedure. So front view is front view will like this. It will be front view with the right half-inch section. Take care about this gap here and also this gap. If you maintain proper dimension, then you will get this gap. Similarly, this top view. So top view is a bit easier. Okay, so you need to show this bearing, the projection of bearing the top half and bottom half, and the shaft. And then section view is also important here. See, this is front view with right half in section. So that means 1/4 of the part, 1/4 of the assembly is removed. When it is removed, you will get the view like this. So the section plane will come like this. Okay. So showing 1/4 of the so that showing that 1/4 of the assembly is removed, and uh, the details will be shown like this. So the section view, sorry, section plane will pass through the assembly like this. This is the section plane. So you need to take this area and the when it is viewed like this. Okay, so this is the procedure of that. So I have not shown the dimension. You please show the dimensions and complete this assembly. Okay, so this is the procedure for drawing the Plummer Block assembly. Hope you all understood, and somehow while doing drawing, right? Okay, so you might have not seen, because of the movement of the sheet, you might have not seen the procedure actually, but you can make out that. Okay, so right, so hope you understood this. Okay, all the best. Complete this and send me the solution in PDF form. Name of the file should be your university statement. Okay, so thank you.